In this section, we're going to take a look at model performance and design. And the work we're going to be doing is going to take place in Framework Manager. We're going to look at how to ensure database optimizations, how to examine your SQL, how to prevent unnecessary local processing, how to check for additional metadata calls at query runtime, how to set prompt info properties to improve performance on prompting, take a look at setting project governors and how some of these settings can affect performance. And then we'll take a general review of best practices for model design. One of the first things you'll want to do after importing your metadata is to conduct some early tests for performance to ensure that the database is optimized. Querying across tables from query items that report authors may commonly use will help to ensure that the relationships between the tables are optimized in the data source and that primary and foreign keys are identified or configured in the data source. A key indicator that there may be an issue with this type of configuration can be seen here in the screen capture in the sales fact table, where 3 keys were imported as attributes rather than identifiers. This indicates that they were not defined as foreign keys and may mean that they're not indexed in the data source. Another item you may want to take care of is to ask the DBA to index items that will be commonly filtered on. With respect to data volumes, you'll also want to make sure that some form of materialization or aggregate tables are implemented in the data source so that for aggregated values, such as facts rolled up to the month level, are pre-aggregated in the materialization or the aggregate tables rather than constantly rolling up the detailed levels at report runtime. As you're conducting your tests in Framework Manager, you'll want to constantly examine the SQL to ensure that it is as expected and that you're not getting more or less SQL than anticipated. You'll want to examine the join paths to make sure that they're correct and that you're going through the correct tables. Examine the cardinality to make sure it makes sense and meets your business requirements. And also, examine the Cognos SQL and make sure that it represents the same as the native SQL. And if not, it's cause for investigating local processing on the Cognos BI servers. Let's take a quick look in Framework Manager and see how we can analyze the SQL. So let's take a look at a quick example here in Framework Manager. We have a model that's based off of a transactional system. We'll take a look at some of the query items that will be used by report authors from retailer, and we'll select retailer region, retailer country, and the retailer name, and test it across to the sales fact table on quantity. We'll right-click these multi-selected items, click Test. We'll click Auto Sum to emulate the default behavior in the studios, which is to summarize the data. And then we'll click Test Sample. Now, knowing the data, I can look at these numbers and see that they are actually off, and the numbers appear to be different than what I expect. So I'll investigate the SQL and see if the SQL is what I expect. My projection list appears to be what I expect, but when I go down to the where clause, I can see that rather than going through the retailer information, I'm actually going through the branch table. So this join path is not what I expect and can also have a performance impact depending on how many extra rows there are in this branch table versus what's in the retailer. But not only that, the numbers that I get back are going to be incorrect because I'm not going through the expected join path. So let's take a look at the business view in the diagram. And we can see that it's just simply model query subjects containing query items from the lower level data source view, as can be seen here. So let's investigate in the data source view. And here we can see sales region, and here's one of the items that was taken for that query, the country, and retailer name that's found in the order header table, and then quantity. And again, if we right click and test here an auto sum down in the underlying structure that has the relationships. We can again investigate the numbers and look at the SQL and see that we are in fact going through the branch table as opposed to the retailer table for our join condition. And the reason this is occurring is that we have an ambiguous join path here. Sales region relates to country, which alt relates to branch as well as retailer site. So there are two possible paths to get through to the order details table. Now because this is a transactional system, you can see the level of complexity or the increased level of complexity in modeling such a system. Whereas star schemas would have everything predefined in their own branch table with branch region, branch country, as well as a retailer table which would have the retailer region and retailer country all contained within one dimension subject. Now to alleviate this problem in this particular scenario, you'd have to create aliases for sales region and sales country and relate them to the branch table and have separate query subjects for region and country relating directly to the retailer's site so that there are clearly defined paths. I'll show you an example of what that looks like in a fixed version of this model. So if we go into the data source view and look at the diagram, we can see an alias created for branch region and branch country that relates to branch, and then a separate set for the retailer site. So retailer region and retailer country. And this clearly defines the relationship path and ensures that you go through the proper tables. So by examining the SQL in the previous example, we saw how we could quickly identify issues, likely improve the performance, and ensure the correct numbers are coming back. As just discussed, you'll want to examine the Cognos SQL versus the native SQL to ensure that they're performing the same actions. And if they aren't, it's a concern for local processing of the data on the Cognos BI servers. Now in the screen example, we see native SQL with two separate select statements. And this is likely occurring due to the fact that we're joining multiple data sources in the Framework Manager model. I suggest reading the DeveloperWorks article called Working with Multiple Relational Data Sources to better understand how to work with multiple data sources and how to prevent joining these two data sources together locally on the BI servers. An exception to the rule for split native SQL is stitch queries. I'm going to show you examples of both in just a moment in Framework Manager. Another item that may cause local processing is when you're using a function not supported by the database. In this example, the @ clause is being used in a total function, and it's causing local processing because the data source does not support the @ clause. Let's take a look in Framework Manager at some of these examples. So here in Framework Manager we have another model based off of a warehouse, and in the business view we're using model query subjects with relationships defined. The first example that I want to show for local processing is using the employee table and reporting across to the sales fact table. Now the performance appears a little slower here, and if we go in and examine the query information and look at the SQL, the Cognos SQL appears normal, but when we go down to the native SQL, we see two separate select statements. The first select statement followed by the second one. Now in this particular scenario, what's causing this is that we have two data source connections defined in Cognos connection. One is pointing to GSDB2, and the second one is pointing to GSDB2 Go. Now in this instance, both are actually pointing to the exact same DB2 data source. And for some reason, it was deemed appropriate to create these two separate data source connections. This does not make sense. So what we'll do is point the Content Manager data source property to the same data source connection for both data sources. Now when we run the test again, we'll see that the results are returned much more quickly. And if we examine the native SQL, we'll see that in fact the entire join condition is pushed down to the data source. Now again, for these two separate select statements, we said the exception to the rule was for stitch queries. And stitch queries are simply taking a conformed dimension, in this case we'll select year and month from the time dimension, and then a fact from one table and a fact from another table. So sales fact and sales target fact. We'll run the test and we'll examine the SQL for this. And if we scroll down to the bottom of the Cognos SQL, we'll see this coalesce function coalescing year and month for revenue and sales target, and it's a full outer join on those two common items. Some database vendors don't support this coalesce function and will send down two separate select statements, one for each fact stream, to the data source in the native SQL. In this case, DB2 does support the coalesce function, and therefore everything is sent down to the data source. Now, if it is sent down in two separate fact streams to the data source in the native SQL, this local processing is typically done very quickly and is not a cause for concern. The last thing that I want to quickly show was using a function not supported by the database. In this case, an @ clause is being used in this function. And if we run a test on this particular query subject or query item and look at the query information, we see Cognos SQL is in fact performing this calculation, but if we look at the native SQL, it's a much simpler select statement and no calculation is being done. A way around that is to use a function that is supported by the data source. A quick way to test out for query items in your model that are performing this local processing is to switch your query processing property in the data source to database only. Now if you test this query item again, you'll receive an error saying that the function or clause is not supported by the data source. And you can quickly do this going through all your query items or calculations that you've created to see if there's going to be local processing and then adjust as required. Another item that may cause concern for performance is when additional metadata calls are done at query runtime. In particular, Teradata shops see large performance degradation when these metadata calls are performed. For other vendors, it's typically not an issue. However, DBAs don't like seeing these extra metadata calls coming in when they're not deemed necessary. In the screen captures seen here, a good message would be that you're retrieving metadata from a query subject rather than from the database. The not so good message is that you're actually going back to the database for your metadata. Let's take a quick look in Framework Manager to see how we can test for this. In this example, we're going to examine what appears to be a simple data source query subject. If we look at the SQL, it's the select star from a particular table, in this case product lookup. And if we test the query subject and then go to the query information tab, and within that the response tab, we'll see the message metadata will be retrieved from the database. And the reason this is occurring in this particular case is because a filter was applied to this particular query subject. Now this message will appear if you add a filter or a calculation or actually go in and alter the SQL statement in the SQL pane. You're modifying it from a simple select statement to a more complex query subject in which the metadata is not trusted at that point and extra metadata calls will be conducted at query runtime. Now if we look at another query subject, such as product line lookup, and run a test on this one where nothing has been touched and it is left as a simple select statement. And we look at the query information tab and then the response tab, and we scroll down and we'll see the message that the metadata for this particular table will be retrieved from a query subject, and this is a good message. So again, in particular for Teradata shops, this is a key point to look for when performance is a concern. Another way to help improve report performance is by setting prompt info properties. Setting these properties can help ensure that filtering is done on index fields rather than non-indexed fields. The filter item reference property is used for the interactive studios. So for example, in Query Studio, if you filtered on product line, the filter item reference would ensure that product line code is used in the where clause or the filter expression within the SQL that's generated and sent down to the data source. The use item reference property is used to create a default value that will be used when you generate a prompt page in Report Studio. So for example, if you have product line in Report Studio and you build a prompt page off of product line code will be used as the use value and product line will be used as the display value. Let's take a look in Framework Manager to see where to set these properties. So back in Framework Manager, let's take a look at the product line query item from the products model query subject. In the properties pane, if we scroll down to the prompt info section and expand that section, we'll see that the filter item reference and the use item reference are set to use product line code. And it's a best practice, in particular, to set the filter item reference to an indexed value to ensure that an indexed value will be used in your filters for auto-generated prompts. We won't spend a lot of time on project governors, but it is important to realize that they can have an impact on performance. For example, allowing cross-product joins can be a resource-intensive type query, which typically returns useless results. It is denied by default. The type of join syntax being used, i.e. the actual join verbiage versus the where clause, can have a positive or negative impact on various database vendors. The same applies to the with clause. These types of governor settings are something to investigate only when performance becomes a concern and there are no other root causes that you can identify. The settings here become the default for the packages, and they can be overridden in Report Studio but not the other studios. It's recommended to read up on the core documentation for more information about these governor settings. Let's take a quick moment to review model design, and the story may be getting old at this point, but it's an important one to stress. We highly recommend going against a star schema database, and the reason for this is that they are designed to have fact tables and dimension tables, and our tools are optimized for this type of structure, and we use the cardinality that is found in the model to identify facts and dimensions. Facts are the query subjects that have only n cardinalities, the ones that are on the many side of a relationship. And dimensions are the ones that have the one cardinality, or are on the one side of a relationship. Performance will be better with this type of structure. We also recommend to leverage the database optimization technologies wherever possible. Framework Manager is not an ETL tool, and it is not an optimization tool. It is used to retrieve metadata from the data source to construct SQL that will be sent to the database at runtime. The simpler the structure, the simpler the SQL that will go down, and the faster the results will be when they are returned.